Arizona Science is supported by Research Corporation for Science Advancement.
For Arizona Public Media, I'm Tim Swindle, Professor Emeritus in Planetary Sciences at the University of Arizona, and this is Arizona Science. Joining me today is Manisha Shrestha, the postdoctoral research associate at the University of Arizona's Steward Observatory, who has been studying a gamma ray burst that's been called the BOAT, or brightest of all time. Welcome, Manisha.
Thank you.
Manisha, I think the first question to ask is, how is a gamma ray burst detected and what is it?
Gamma ray bursts are actually one of the most energetic events in our universe. So when I say the most energetic, what I mean is like in few seconds, the amount of energy this produces is actually higher than the amount of energy produced by our sun, for example, during its billions of years of its lifetime. So it's that energetic.
How do you detect these?
We have dedicated satellites. So because these are gamma rays, that's how we detect it. Most of the satellites we use are in space because gamma rays get scattered when it comes to Earth. So we try to observe it. So we have satellites like SWIFT, which is a NASA mission, which is made to detect these gamma ray bursts.
How often do these things happen? Do these happen inside our galaxy?
No. So within our galaxy, I think we will have like once in a millennium or something like that. In general, we usually detect one per day or less, but this is very unusual one. This particular with this much of energy, we have expectation that there will be another one in 100,000 years or something like that.
How much brighter is it than other gamma ray bursts that you normally detect?
I cannot tell you exactly like what was the ratio, but it was way, way brighter in gamma rays and X-ray than anything else we have detected ever.
What was your part in studying this?
I led an effort here in Arizona in terms of studying the progenitor or the kind of star that exploded and created this gamma ray burst. So this was such an interesting object because it is super close, very bright. So it means that we can actually look at it and try to gain as much science information as we can. And one thing we were very interested in knowing was there something peculiar or interesting about the star that exploded and created this much energy of gamma ray bursts. So we were looking for something called the supernova side of it. So when this massive star explodes, you have the jet, and then this jet interacts. That is where the gamma rays are coming from. And then there is also all the other stuff that is going everywhere, not in a jet, but everywhere else. That is the supernova emission.
Was there anything unusual about the supernova?
Yeah, it was very, very puzzling. Like, I think that was very exciting because we always expect for these kind of gamma ray bursts to have a supernova component. And the way we detect it is usually either in two different ways. One is to look at how light evolves or the brightness changes with time. So what happens with that jet emission is that it decays with time. Just the brightness decreases with time and it keeps decreasing. But once the supernova starts to emit light, then we see this nice little bump in the brightness.
How did you find out about the gamma ray burst?
How we do is we work in a community manner where as soon as there is this burst happens, the SWIFT, the satellite I was saying, it sends out this email we call the GCNs or the coordinated circulars. So we get this information that this burst happened today. So we got instant email. After that, people start following. All of us actually email in this whole group where everyone gets this email saying, oh, what was the brightness of this gamma ray burst, how energetic it was. So in our community, we share this information so that it is easier for us to coordinate this observation so that we know which kind of telescope might be better, because if it is too faint, we won't be able to get it with 1 meter class telescope. We want to go to the larger one. So we always circulate this information. So that's how we find out about these bursts.
Well, thank you for discussing this with us.
Thank you very much for having me.
Our guest today has been Manisha Shrestha, who has been studying the brightest gamma ray burst in human history. This is Tim Swindle, and you have been listening to Arizona Science. You can also listen to this and other Arizona Science segments by going to the Arizona Public Media website at azpm.org.
Thank you to Research Corporation for Science Advancement for their support of Arizona Science.